Hi, everybody, and welcome to another episode of Ok Xoomer. I'm your host, Aaron Lichtig, Xometry guy and former Jeopardy champion. And I'm excited to be here today with Michael Raphael. And Michael is the founder and CEO of Direct Dimensions. It's a company headquartered right here in Maryland, Owings Mills, Maryland. And they provide 3D scanning and digital modeling services to a wide range of industries and applications. Often for manufacturing, architecture, the arts, and even Hollywood movies. So welcome, Michael. It's great to have you here.
Thank you very much, Aaron. It's great to be here.
Awesome. So tell us about Direct Dimensions and the work you do there.
So Direct Dimensions, we're deep in the 3D scanning business, right? So we're on the input side of digital manufacturing. 3D printing, additive manufacturing is all about taking things out of the computer and bringing it into the physical world. We kind of do the opposite. We put things in the physical world into the computer in 3D, often for 3D printing and additive manufacturing purposes, but there's many other applications for why we would 3D scan things and put them into the computer.
Awesome. Now, what are some of the coolest projects that you've done, ones that have really stood out for you?
So we've been doing this a very long time. Many years ago, I helped develop some of the technology related to 3D scanning. And so we've had this company for 25 years. And you name it, we've scanned it. And to your point, Aaron, about some of the coolest projects, I mean, some of the most cool are some of the sensitive things that we probably can't talk about related to the federal government and, things in Washington, D.C., and also things in some of our, related to some of our military applications out and about. They're probably the best and the coolest. Having been on nuclear submarines, having been in the White House doing scanning, and many other monuments and sort of places like that, it's pretty exciting. I'll never forget probably the coolest one, Aaron, that I'll tell just a little bit of story about is getting a phone call. This is probably 10 years ago. Getting a phone call on a Wednesday, and some folks said, "Okay, we know who you are, we know what you do, and you will be here on Friday," in the middle of Washington, D.C., I might add. And sure enough, we were there on Friday, and we scanned something rather interesting. It was actually related to the limousine for the president for an inauguration ceremony, right ahead of the inauguration ceremony. And because of the idea of putting special components and special equipment inside very rapidly was sort of their goal. I'll leave it at that.
Excellent. Now, we recently partnered Xometry and Direct Dimensions on a project to reverse engineer a part and then 3D print it for the chair, the beloved massage chair of a Missouri farmer, Ricky Davison. How did you work on that project? How did that come to life?
Very typical, very normal for us. In this case, Greg Polson, who you know at the Xometry, who we've known for a long time, a big fan of ours, and we're a big fan of his and Xometry, of course, especially being in the state of Maryland together. So Greg's been aware of us, our capabilities for years, and the idea of scanning things is obviously what we do. In this case, it was a very small part that could be easily sent to us, shipped over. It was kind of a gear mechanism, small gear, linear gear actually. And, apparently I guess Greg and his team got wind of the fact that this poor fellow was suffering with his chair. He couldn't get the manufacturer to fix it. So Greg said, well, let me take a crack at it. I think 3D printing could help. Oops, I need a CAD file, as you would expect, to do a 3D print. So light bulb went off immediately. Call Michael at Direct Dimensions. Those guys are always willing to help out, which we were. We scanned it. We completely reverse engineered the geometry that we captured from the laser scanner. We probably used, in fact, I'm certain we used a laser line scanner on an articulating arm to do this. It's got a high degree of accuracy and precision, less than 1,000th of an inch or so, as we scan and model this whole thing into a CAD model that was then sent back to Greg, and he put it through one of the printers over there and sent it off to the fella. They installed it. Apparently it worked like a charm and made it to the news, which was very exciting.
Excellent. Yeah, it was a great project. It ended up on Fox 4 in Kansas City. Pretty cool one.
Yeah.
So how did you get your start in the 3D scanning industry?
Great question, Aaron. So I came out of engineering school, Virginia Tech, and as an engineer, I went in the mid mid-'80s and went right to what was then a Martin Marietta facility here in Baltimore. Later, a few years later, it got acquired by Lockheed and became Lockheed Martin. While I was there, I was responsible for solving measurement and manufacturing and engineering problems throughout our aerostructures that we were building. And CAD, we were just starting to use CAD in 3D back in the day, and this is late 80s, early CAD, and we were building parts, and the parts weren't exactly equaling what we saw in the computer, so we wanted better ways to measure these parts. We found a company in Florida called Faro, F-A-R-O, and we started working with them very early. We were, at that point, 100% a medical products company. We showed them these problems that we were having, some of the opportunities related to aerospace and other manufacturing applications, and they got very excited, and we helped them develop essentially the industrial version of their medical product into what's now known widely across the world as a Faro arm. We became their first customer, first user, got a unit. We started measuring parts. A few years later, after having some experience in this factory environment, working for Lockheed Martin, I quit the business, quit my job, started Direct Dimensions, bought a Faro arm, became a reseller as well as a service provider with this tool. Fast forward 25 years, and we've added a lot of tools from a lot of different companies from around the world. We developed some of our own tools, which are very interesting, especially lately and recently. And all of the things that we get involved in are anything related to 3D scanning, whether it's very small or very large, and everything across the spectrum. We're kind of unique in that sense, having done this for a very long time and doing it very, very broadly. So there's not much we say no to, and that may be the reason we have expanded the way we have across these industries. From industrial and manufacturing related things to architecture and buildings and facilities to art and sculpture and museum and historic preservation. And as you mentioned, we're very deep lately in the Hollywood movie scene, where we support the production of virtual effects in movies, right? The big budget movies that, where they want to blow up people, but not actually blow up people. So they do all that in the computer, and there's a lot involved, and we scan the sets, the props, the vehicles, the actors, prosthetics, and the actors. And it can be very exciting. Although I haven't seen much of it. I send people to those things and
so
haven't seen much of it myself.
You're actually scanning the actors' bodies.
Yeah. Oh, quite regularly. We've probably done close to 50 productions over the last 10 years. The first one being Black Swan, if anybody remembers that movie, a great movie with Natalie Portman. It's actually one of the only films I went to the production site to see myself. I wanted to meet Natalie, which I did. It was very exciting. And while we were there, we scanned her. And back 10 years ago, we used somewhat conventional technology, some of the same scanners we would use to scan buildings even, or historic preservation sites. Fast forward a few years, we've developed technology around the term photogrammetry, which probably some of the listeners have heard of. This is the use of cameras. You can use a single camera and you can take lots of pictures of something and convert that into 3D. It's becoming more common. The problem is people move, right? So you take a single camera and you run this around a person, they're going to move very quickly, and that's not going to work. So what we do is we developed a rig of cameras. Current rig is 128. We're about to add 32 more. You stand in the middle. It's a big cylinder of cameras and lights. You stand there. The lights and the cameras all flash for one split second, and that's it. You're done. We're captured. We then take these photos and we convert them using software into 3D versions of you, and it can be incredibly compelling, very accurate, literally getting capabilities down to the pore level, which is amazing. It's get full color. It's well lit, and we can do some special sauce to get even remove some of the shiny components of people's faces and things like that, or things that they're wearing. And it's exactly what the VFX folks need and desire in movies. And it's really filling a pipeline and becoming very common, actually, for the production of movies and commercials and TV shows these days.
That's fascinating. Now, the technology has come so far since even 2009, when the Black Swan has released. Looking out another 5 to 10 years, what are some of the newer technologies or newer developments you think are going to happen in scanning and modeling?
Right. So good question. Oops, let me get rid of that thing back there. Sorry.
Oh, there we go. Yeah.
Yeah. Okay. And if I could, 1 second, I'm sorry. Okay. So some of the newer technologies absolutely are the idea of the idea of doing photogrammetry to capture objects is becoming fast and foremost the technology that we're working on. So we took the concept of the full body scanner that we're using quite regularly for film production, and we're actually minimizing that and reducing in size the camera rig for the purposes of scanning parts. So we've done this, and we've developed this for some certain applications related to additive manufacturing, as a matter of fact. The ability to capture lots of parts very quickly, very quickly in an automated fashion, to create the CAD models and information that would be used to develop which parts you might 3D print, which parts have components of which that could be 3D printed, which parts might be designed to take advantage of the capabilities of additive manufacturing as opposed to conventional manufacturing. So this is a really exciting new direction for us. We're working with both federal government clients as well as commercial parts manufacturers and folks that are worried about part stock rooms and supply chain considerations. But another application that we're finding is for museums and folks with collections, because they can digitize some of these collections rather quickly, and some very interesting applications related to that as well.
Excellent. The future is bright. Well, Michael, thank you so much for joining us today on OK Zoomer. It was wonderful to have you.
My pleasure. Thank you, Aaron. I appreciate the opportunity and look forward to continuing our relationship with Xometry.
All right. Thanks, Michael. And audience, thanks for watching. We will see you again soon with another episode of OK Zoomer.